So now that we have the equations pulled from the equality of the two given matrices, we can go ahead and solve them. So for the first one, we just are going to get, actually, let me move this down really quick. Nope. I'm not doing very well here, am I? So for the first one, 3 minus x equals 2x. We add an x to both sides, so we get 3 equals 3x, and we'll find that x equals 1. So that's the value for x that we were looking for. In the second equation, we have that z squared minus 16 equals 0. So we can just use the square root property by moving the 16 over to the right and forming the equation z squared equals 16. Taking the square root of both sides, we'll cancel out the square, getting that z equals plus or minus 4. And then the last equation here, 3y equals 10. Oh, 3y plus 10 equals 4. Forgot the 4. We'll just subtract 10 from both sides to find that 3y equals negative 6, and our result is that y equals negative 2. So the answer for this question is that x equals 1, y equals negative 2, and z equals plus or minus 4. And we'll do a similar method for this other example here. So what we're going to find is that 5x minus 14 needs to equal negative x squared. Y needs to equal 0. And 6 needs to equal z squared, 2z plus 12. So I'm just going to write those out. (5x minus 14 equals negative x squared). So here we're going to get a quadratic. I'm just going to move the x squared over. So this will become x squared plus 5x minus 14 equals 0. So from there we can go ahead and factor. We'll get x plus 7 times x minus 2 equals 0. So our solutions for the x value are that x equals negative 7, and it can also equal 2. For the next one in pink, we get that y equals 0. And there's nothing to do there, right? We don't have to solve that. We just know that y equals 0. So we get y equals 0. And then for the last one, we're going to get that 6 equals 2z plus 12. I'm going to subtract 12 from each side. So I'm going to get negative 6 equals 2z. And then from there, I'll divide each side by 2. And I'll get that negative 3 equals z. So then here, z equals negative 3. And so those are the solutions for this equality of two matrices in example 3. The next topic we're going to tackle is kind of a prelude to assignment number 51. It's this idea of kind of like solving for one variable and then using that to back substitute to find the other two missing variables. So the first thing that you want to do is we're going to plug z equals 5 into equation number 2. So we're going to call this equation 1, equation 2, and equation 3. And this is a really common way of identifying which equation you're referencing. Okay, so if I do that, I would get y minus 2 times 5, because again, z is 5. This equals negative 8. So I have y minus 10 equals negative 8. I add 10 to both sides and I find that y equals 2. So then the next thing I'm going to do, so this would be step 1. Then step 2 is plug in z equals 5 and y equals 2 into equation 1. So equation 1 says x plus 2 times the value of y, we found y to be 2, plus z, which we know is 5, equals 9. So we get x plus 4 plus 5 is 9. This equals 9. I'm going to subtract 9 from both sides and I'll find that x equals 0. So our answer then is that x equals 0, y equals 2, and z equals 5. So in the next section, we're going to learn how to put a linear system in terms of a matrix. It's called an augmented matrix. And so we're going to learn how to transcribe equations 1, 2, and 3 into a matrix and then do some what we're going to call row operations to get this answer a little bit more efficiently. So we'll do the same thing here in this next and final example. Oh, just kidding. This next example. So step 1, plug z equals negative 1 into equation 2. And again, this is equation 1, equation 2, equation 3. So when we do that, we'll get that 5 times y plus 3 times z, which we know is negative 1, needs to equal 2. So let's go ahead and simplify that. Add 3 to both sides, and we find that 5y equals 5. Therefore, y has to equal 1. And then the second step, as we did in the previous example, we're going to plug z equals negative 1 and y equals positive 1 into equation number 1. So equation 1 says 15x plus 6y, which we know is 1, plus 2 times z, which we know is negative 1. That all needs to equal 4. So I'm going to go ahead and simplify. 15x, 6 minus 2 is 4. That still needs to equal 4. So subtracting 4 from both sides, we get that 15x equals 0. Therefore, x also equals 0. So for our solution, we get that x equals 0, y equals 1, and z equals negative 1. In the last two examples here, we're asked to perform a specific row operation. So these are a little bit different in character than the previous two examples, because in the previous two examples, it was let me just scroll back. It was so nice what we had. In the first equation, we had x, y, and z. In the second equation, we had y and z only. And then in the third equation, we had z by itself. And so that lent itself really nicely into kind of just back substituting until we got x and y. In this next example, what we're going to do is we're going to combine two equations to get a system of two variables and then solve that system. So we're going to combine equations 1 and 3 to eliminate x. So again, you're looking at 1, 2, and 3. So for 1 and 3, for 1 and 2, if I wanted to eliminate x, I might think that multiplying the first equation by -3 would achieve that. So I'm going to multiply the first equation by -3 and add it to the second equation. That's how we're going to eliminate x. So I'm going to get -3 times x minus 4y plus z equaling -2. That becomes -3x plus 12y minus 3z equals 6. And I want to add that. So just to be clear, this is 3 times equation 1. And then I'm going to add that to equation 2. So equation 2 is 3x plus 2y minus z equals 4. And so I just add it term by term. So I'm going to get 0x, which is what we wanted, 14y minus 4z, and that's going to equal 10. The other thing I need to do is I need to combine 1 and 3. And I also would still like to eliminate x. The reason why is that if I can get another equation and just y and z, then I'm set. I can go ahead and solve for y and z, and then I'll use those values to back solve for x. So if I wanted to eliminate x, I think what I would do is I'm going to multiply the first equation by +2, and I'm going to add it to the third equation. So I get 2 times the first equation, x minus 4y plus z equals -2. And so that's going to become 2x minus 8y plus 4z equals -4. And I want to add that to the third equation, which was -2x plus 4y plus z, and that equals 3. So if I go ahead and add these guys, I get 0x again, which was the intention, so we're on the right track. My y's, I have -4y. I have 5z, and that all needs to equal -1. So now what's happening is that I'm going to rewrite the equations. So what I'm really looking at is two brand new equations. 14y minus 4z equals 10. And I also have -4y minus 4z. Wow, Kelly. -4y plus 5z equals -1. And so